I hope you're enjoying the conference so far. Kube, I'm actually happy when I see familiar faces. I sincerely hope that you're enjoying the conference so far and that doesn't change after my talk, please. Okay, so my name is Didier de Cesare. I'm employed by Red Hat, and I'm based here in this beautiful city of Barcelona. And I'm sorry to break this to you. I'm not a DevOps engineer, but hey, don't shoot the messenger just yet, okay? I promise you I'm here to share with you something which is relevant to basically anyone sailing the untrustworthy waters of cloud-native development. So, keep being honest with you. I'm going to fully state my affiliation that extends a bit beyond Red Hat. I'm one of the co-maintainers of the sandbox, CNCF sandbox project named Quadrant, where we build services for connectivity and security cloud-native applications. That doesn't mean I'm an expert, not an authority in the topic. So please mind that disclaimer when the Q&A comes. And my goal for today will be to make you think when you develop application for the cloud-native, that there are like probably many things that you can delegate to the platform itself, instead of like making your business logic with things like, as we're going to see today, security. All right, so this is our roadmap for today. We're going to start by leveling the definition of cloud-native, native of the cloud, works in the cloud. And just to quickly jump into pinpointing the aspects of zero trust that describes the approach, basically, of the strategy, the design, and the implementation of the security of your IT systems. So we're also going to talk about authentication and authorization. We're going to enumerate some methods and models. And of course, we're also going to see how they work together, closely together, but they're not the same. Probably we can do an analogy. If you have a doctor appointment, for example, and you get to the clinic, and you need to present, if you are in a well-developed country, that the government cares about your sanitary system, your sanitary card, if not your health insurance card, and they require you to present your ID as well that has a picture of you. So the idea is to authenticate that it's yourself, identify you. Okay, this is the same picture, this is my face. And then, okay, so I'm actually allowed to use the services of this hospital. Another example would be if you're like flying somewhere, before you take on board in the plane, you're required to show your ID and your boarding pass. If not, well, you're not boarding that plane. So then we're going to, well, I'm not sure if like anyone is familiar with Gateway API specification from Kubernetes. Raise your hands if you're aware of that specification. That's really good. We have like a couple here. Good. So, spoiler alert, Ingress is going to be frozen, and all the new development is actually invested in the Gateway API. It's going to be the replacement, not only for the Ingress, but load balancing and mesh networks. And of course, I need to prove you what I'm actually talking, so we're going to show you in a demo. All right, so if you visit the website of the CNCF, and you're going to find like a definition of what is cloud native. The first part of the definition includes like a lot of workloads in the cloud service. Pretty much everything beyond bare metal, it is meant to be, nowadays, it's meant to be cloud native. It doesn't mention anything at the very beginning of containers or declarative APIs. But if you keep reading, it sounds like saying that there's a combination of containers, service meshes, multi-tenancy, microservices, immutable infrastructure, serverless, and declarative APIs. As of today, 14th of November, 2024. I think like the go-to platform that comes to mind, it starts with Kube and ends with Netis. So, like it or not, that's the default. So much, but so much, that its declarative API has transformed the software development into YAML development. So we are YAML engineers nowadays. Probably prompt engineers some, but well, there's some truth in that. OK, so, but I don't want you to think only about Kubernetes, like, OK, we're going to, it's like a container orchestration platform only. What I want you to show you to think about is you leverage Kubernetes capabilities to do so much more. And we're going to see in the demo. You can delegate a lot of your concerns of your application to Kubernetes itself. OK, so jumping into Zero Trust. Let me try to put you an analogy that serves as an example about Zero Trust, but how it was before. I mean, if you need to think about another architecture when everything was on-premise, we think about, like, not many years ago. We have a couple of servers. The analogy goes like a castle and a moat. That the castle would be, we need to defend the queen. We put the queen in the castle. We invest a lot of resources into fortify the walls of the castle. We invest resources to dig a moat surrounding the castle. We need an elevating bridge, of course. Heavy iron gate, sorry. And of course, like probably towers with guards. This analogy could compare to, you have like your servers, and you invest a lot of effort into have a really good firewall, intrusion detection systems, and intrusion prevention systems as well. And that looks like it worked pretty much well. To an extent, I mean, like it works really well for external attackers. But what happened when the attack comes from within? A revolution starts brewing within our castle. And then, soon next, Marie Antoinette meets la guillotine. And voila. That's it. The kingdom is over. Vive la France. So, this goes into the servers that when an authenticated user within the network can have access horizontally to any pod, for example, if we do an analogy with Kubernetes. And that's one of the biggest flaws, but nowadays, the technology and every business, they are scattered in different vendor platforms like Fastly, Clever Cloud, AWS. So this analogy doesn't work very well. You cannot defend the castle when your queen and the cohort are scattered in the countryside. So that's why we need to care about a different approach to security in our IT systems. And comes like Zero Trust, which is an approach. In a nutshell, we can say that no request is safe by default. We live in a world, in a state of constant paranoia, basically. And that doesn't sound very good, but it is probably effective. We never trust. We always verify. We run only the minimum access. That's the principle of least privilege. So if a service, a pod needs to access a database, it only needs to access that database, that Redis database. And limiting the blast radius, we need to minimize the impact of any potential breach. We quarantine a zone. If, like, for some reason, an attacker got access to that zone, it cannot invade the next one. That pod was compromised, doesn't need necessarily to go to the next pod. And, of course, this can go on with encryptation of like any repositories and messages and many other parts. But what I want you to focus is on authenticating every single request. Verify the ID and authorize any kind of interaction within or coming to your system. Okay, so instead of going in a rabbit hole of definitions and how we can mitigate and how we implement all these approaches for having a zero trust system, I propose you to let's try to a solution to the remedy that would be using external auth proxy. And of course, there's a lot of criticism about using proxies. And first, proxies are not sidecars. They are sidecarless approaches, as we're going to see. Proxyless approaches, they do exist. If you're confident enough, you can meddle with your kernel. eBPF is an amazing technology to do so. Back in an opportunity in the past, in my self-experience, having mixed up your business logic with security and authorization, that turns to be unmaintainable, and a spaghetti code that turns to a spaghetti monster, and then you have a religion there, Pastafarianism. And so, yeah, do proxies punish performance? Do proxies are like another point of failure? Well, that's kind of true, isn't it? Well, you're adding another network node in between your clients and the services. So there's some truth in that. But to be honest, the technology of the proxies and the gateways nowadays is extremely reliable. And those minimum nanoseconds of delay that probably going to happen in the first request versus all the capabilities of the proxies today, from caching, routing, and security within the proxy, I think we balance this, and it goes to a favorable approach. Okay, so as I mentioned, authentication and the analogy of having your ID or your passport issued by the government. Some of the methods, and the first one that I have listed here is API keys, and yeah, they are still widely used. Even of all the flows that API keys have, they are still used. They are not going anywhere, like it or not. We have a more robust method that would be OIDC, which is built on top of OAuth, which the good thing about this is this is actually really good, extremely good for stateless applications, because OIDC issues a JSON web token, which has a lot of user and session information within the token. So for a stateless application, that's fantastic. We have certificates as well. A server can have a certificate to authenticate itself for a client. The same way, we have a client with certificates that can be authenticated to the server. So that's actually mutual authentication, mutual TLS. And something that I want to highlight today, it is a Kubernetes token review. What I mean with this, probably you weren't aware, but you can use also this token review API from Kubernetes to authenticate tokens, service tokens, access tokens, and even actually tokens coming from any IDP. It's actually pretty good. We'll see. From the point of authorization, we have these JSON web tokens that they were issued by OIDC. A particularity of these JOTs for short, that there are 3 parts that are included in the token. The first part, it is the information of the user and the session. Then we have a set of claims about that they match the resources that you probably want to access in your application. And then you have the signature of that token. So a single pattern matching, we can actually grab the claims within the JSON web token, this JOT, and matching to cross-related to these resources that they are meaningful in our application. Another model would be the attribute-based access control, or ABAC. It is also known by auth policies as well. There's like the open policy agent technology. They are doing a really great job with its language rigor, that they cross-relate data from the user and the session with other resources that you want to access. There is like a list known, I would say, like, which is REBAC, which is relationship-based access control. This basically models permissions based on the relationship between the entities of the database. It is gaining popularity. I haven't seen it widely used in production. Of course, it is implemented somewhere. And then we have Kubernetes Airbag. OK, this role-based access control, it is a default in Kubernetes, meaning that probably you know when you you define some roles, then you bind those roles to users or to service accounts, and then you can use probably, you can escalate pods, you can actually do create deployments, read secrets, config maps. But probably you didn't know that you can use the same airbag system for resources that they are meaningful for your application only. And this is thanks for the subject access review that is going to be authorizing based on the information coming from a token. OK, so I wanted to tell you a bit about Gateway API. I already told you that it's going to be the next thing. Ingress is getting replaced. Gateway API, it is a new thing. It has been designed from the very beginning thinking about roles. So this is for a separation of concerns and to make it easier to delegate different tasks for different teams or different structures of different companies even. So there are 3 roles, as you can see. Infrastructure providers, that they are going to be, most of the time, working on networking objects, the gateway class. We have like cluster operators, that these cluster operators are going to be working on the gateway objects. And then we have application developers, that we have like many resources, many objects, as the TLS route, the HTTPS routes. We have also gRPC routes. So in its design, it's also bear in mind that its portability, it supports multiple implementations. Any gateway implementer or provider, you define just once, and then you take that specification to the next one, and in theory, it should work. It is expressive, so it provides advanced routing capabilities. As you can see, the objects here is actually very expressive in the sense like, yeah, TLS route, you probably already know what it is about. If you see gateway object, OK, well, it makes sense. And it is extensible. There's like a lot of meta resources associated to the objects of the Gateway API. That allows for various layers of extension for these objects. We are going to be interested in one meta resource, which is a pattern called policy attachment that is part of the Gateway API specification, which it gives us yet another layer of expressiveness to define not only the networking of our systems, but also a policy enforcement layer based mainly in security. So some differences with the Ingress specification. Well, Ingress only works in layer 7 for HTTP and HTTPS. In the case of Gateway API, we also have options for L4. So UDP, TCP, you can act on that level as well. in terms of portability and extensibility, you know, if you're used to configure ingress, it relies a lot on vendor annotations. So that's very difficult to port to another provider. It doesn't work, really. But in Gateway API, we are already given the tools, and it facilitates us for be expressive and to take our specification to the next one. And of course, in a Gateway API, we have 3 personas, while in Ingress, we only have one, which is the application developer. And I already mentioned that the standard goes, actually, Ingress is already frozen. I think that's already communicated. And all the standards, all the new implementation goes to Gateway API. OK, to do a quick recap here. When we talk about cloud native, what I really mean in terms of the scope of this presentation, it is that we're going to be using Kubernetes as a platform and its API language, and for configuration of our services and entire infrastructure, and using the policies as well. Zero trust, we're going to be minding only that every single interaction with our system needs to be authorized and authenticated and authorized. And we're going to be leveraging these Kubernetes tokens for auth in general, using the APIs of token review and subject access review. And we will see how Gateway API makes it super easy for us to define the topology of our entire system, and as well how policy attachment, this pattern is going to be super useful for defining the security of our system as well, for protect our application. OK, this is demo time. I hope like the demo gods abide my demo. Hopefully I behave. What you see in the screen, it is how our cluster is going to end looking like. We're going to start from a really simple topology, and it's going to end up looking like this. Also, if you want to follow along, you can go to the QR or the link. And one particularity of this demo is that you're going to see that every single service and product that I'm going to be using is a CNCF project. Everything open source. So OK, let's see if this works, actually. And I think I'm going to need assistance. See. No, it's lost in I don't know which screen. No. Sí. Sí. Jump to the other screen. I found it. So if you please can move towards this to here. All right, fantastic. Great. All right. OK, so The stack that we're going to use for Kubernetes Gateway API. We're going to use Istio. I know that, for example, that Istio is very famous for the mesh capabilities. We're going only to use it as an ingress gateway here, for this demo, at least. We're going to be using Quadrant, Set Manager for issuing the certificates, Quadrant for the policy attachment, for defining policies to secure our application. And we're going to be using MetalLB as a load balancer. The requirements for this, if anyone wants to follow along, are Docker or Podman, kubectl, kind as our local Kubernetes cluster, Helm for installing the operators, good old curl, and Docker Mac Connect or Podman Mac Net Connect, in case you're using Mac. OK, so I already took the liberty to advance in the steps, because there are like many operators and container images that they are like extremely heavy, or well, heavy for all of us today on the same Wi-Fi network. So, but if you see the cluster, let's see if this works. I'm going to Alt-Tab. I don't know what's going to happen. OK, no, I'm going to show you here. What you can see, if I have this deployment that you can see on the left, which is our application, there is a simple news agency application where you can push and pull news articles. This is an image, and it's listening on the port 3000. We can see that it's here. Mine, that it's been 6 hours and 25 minutes that I have it running, because I really didn't want to. I downloaded this image, and it was like, OK, it's going to stay there for the entire presentation. But mind that number. Then I already installed Istio as well as our gateway provider. We have MetalLB for the load balancer. These are for kind. We already know that. We have Set Manager for issuing the certificates. And we have a couple of operators from Quadrant to applying these policies for our security. So if we export this port, we managed to access our service. And yes, we are. Mind you, like now, this is how it looks like. We are accessing the service we're accessing our application exposed by a service. Of course, we are like port forwarding the port so we can access directly. This means like HTTP, the port, we directly consume our cloud-native application. In the next step, we're going to do the same, but we're going to do it through a gateway. So I install the gateway API specification, the load balancer, that I already have it, of course, the Istio gateway controller, and this is where I want to show you how expressive gateway API is. I think like anyone that can read this YAML file can understand it, I suppose. I don't know. Kind gateway tells us something. You know, the name and the namespace, this is, of course, like a Kubernetes object. Then we have a gateway class. This is for Istio information that is irrelevant for us at the moment. And we're going to use the protocol HTTP and the port 80 for anything.io. We apply this, and we're going to see that this is new, 10 seconds ago. We applied that object, that gateway object, that YAML, and the Istio, the sale operator, already say like, oh, okay, this is actually of my interest. I'm going to create a gateway. So it deployed an ingress gateway for us. Now, the next step, we're going to apply a similar object as we've seen in the diagram of the Gateway API specification. This is an HTTP route. And it's meaningful to application developers because that's the level before of a gateway for the cluster operators. The HTTP route is at the level of app developers. We connect a gateway to our service, to our application. You can see that the parent ref is actually our gateway object that we have here. It matches. For the host names api.news.io, which it is within the everything star.io. And this HTTP route is going to have some rules matching some methods. In our case, post, get, and delete. And it connects to the backend ref, our cloud-native application, our service of the News API on the port 3000. I'm going to export the IP of this gateway so we can access it. And we have a 200. So what happened in this step? It's pretty much the same, but with an indirection of our proxy. So instead of going directly to our service, we pass through a proxy that we configure it only by defining that gateway object and that HTTP route object. We see as well that we have the load balancer and the Gateway API controller installed in our cluster. So far, nothing really changed. You can see that our News API, unbothered, gaining more minutes available, but this is not secure still. So the third step of this guide is going to be about start applying some security layers. We're going to start the cert manager that I already have it installed. Quadrant for the policy we already have installed is our policy enforcer. But what I'm going to do is request some services from Quadrant. We can see that we have like author inner, limitador are new, and we see how they are configured. So imagine now that we already have the cert manager, and we have the policy enforcer installed in our cluster. We want to configure our ingress proxy to, instead of managing HTTP requests, to manage HTTPS requests. So we're going to apply TLS. And we do it just modifying the gateway object that we had before. It is the same one, that instead of the listeners being the port 80 and the HTTP protocol, we're going to use HTTPS on the default port. And that we have like some certificates of kind secret and with the name ingress gateway cert for start.io, anything that goes to that gateway. We create a cluster issuer object, which is meaningful for our certificates, for the cert manager. And then we defined a policy. This is part of the policy pattern from the Gateway API, policy attachment. That the target reference is the gateway, the same gateway, the only gateway that we have configured, and that the issuer is a kind of cluster issuer with this name, which is this one here. just like that, we go and, well, first of all, you know that I'm resolving with curl API news.io because I invented this for this demo. It's nowhere there. And then, if you know, we are self-signing those certificates. So we don't have like a CA, an authority to validate those certificates. For the purpose of this demo, if we pass the insecure flag, let's see if we can access our service, and we can. So far, the topology and the request flows looks like this. We are going through the gateway. We are accessing our service, but this is actually, at least, is an encrypted communication. Thanks to cert manager issuing those certificates that they are self-signed, and Quadrant for enforcing the TLS policy, saying like, anything that goes to that gateway needs to be requesting this certificate with that name. Okay, this is actually good because at least the communication from the client to the service is going to be encrypted, so no one can actually spoof that. But anyone can actually access our cluster, our service. So the next step that we're going to do is create another policy. And this policy, it is going to be applied to our HTTP route, which means like the application developer will do this. And in this, under the rules, we're going to, in the pipeline, we're going to apply only authentication and authorization. For the authentication, we're going to use the Kubernetes token review, as we've seen before. For this is the default audience of the tokens. And on the authorization phase, we're going to use the subject access review API. For the username selector, the resources is going to be our news API, io.io, and the selector is going to be the request method, get, post. And for the resource that we're going to protect, it's going to be the first position after of the path, basically. So we were hitting / sports, so anything sports or economy or anything from the news, that's what we're going to protect. So now if we try to access the same way, we get a 401. So defining that policy, we already apply some authentication and another barrier for any attacker that wants to access it. You need to be authenticated. And I told you that we were going to use Kubernetes access tokens. So we're going to create, we need a user first. For this demo, the easiest way of creating or representing a user, it is a service account. So we're going to create a service account called Alice. And we're going to try again. OK, there you go. There is no 401 anymore, which means it's been authenticated, but it's not been authorized. It's not enough permissions. So we're going to use RBAC for this case. We're define the API group news API IO, which is the same one that we define in our auth policy. For the resources, sports, and economy, we have 3 roles. The publisher, that has the most permissions for more resources, sports, and economy. For the verbs post, get, and delete, we have another one, sports reader, just for sports and get, and an economy reader for economy, and for the verb get. Let's bind those roles to our Alice service account. The same way that you would go for any service account for accessing deployments or config map of secrets. So we do so, and we're going to try hitting the same endpoint, but this time adding a header, the token that we create with kubectl. And now we have a 200. Of course, it's actually empty, but it returns because there is like nothing in our service. If we try a forbidden endpoint as economy, for example, we return a 403. So the policy is being applied, it's being enforced. We can create another user, Nico, and we're going to bind that user to the publisher's role. That, as you remember, it has like more resources and verbs. So you can do a post to sports. And then if we can read that from the user Nico, and we can see that works. But let's try Alice. Alice has permissions for sports, so let's try it again. And now we receive from Alice a 200, and we can read the news with that user. Okay. This is how the topology looks like now. The request comes to the gateway, but now the gateway, the proxy, knows that it needs to enforce not only TLS, but also needs to authenticate and authorize that request. That it's been only used for a TLS policy and an auth policy, where we define within our auth policy the token review and the subject access review phase of authorization. Then, now, our request is fully protected. Terms like you need to be authenticated, authorized, and it's also encrypted. Let's take a look at our service. News API, our application is still adding more minutes in its lifetime. Let's add yet another layer of security. Let's add a rate limit policy this time. So we're going to define, it's like in a window of 10 seconds, we're going to limit to 2 requests for the same HTTP route that our News API service lives. So we try 2, and then we get like a 429, too many requests. If we try another endpoint, we get the same. So this is the end result that we have with in our cluster. As we can see, we are applying for that communication, for that request, we are encrypting that request, we are applying authentication, we are applying authorization, and we are rate limiting every request. Leveraging Kubernetes roles, role bindings objects, and the use of the policy attachment pattern to express that configuration that we want to secure these services. And we didn't have to redeploy, not even once, our service. Oops. Our News API has been available so far, and pretty much everything that we did leveraging all the capabilities of Kubernetes. So let's go back to the presentation, if it's possible. I have yet another slide. All right, it's not possible. But, well, anyways, I hope that I can actually prove my point today, that it was able to leverage all the capabilities of Kubernetes, of the platform, that there are like many things that you can delegate to the platform itself, especially for security, and for all our zero trust approach in security. Hey, you came back. And wait. And I just wanted to let you know that there is like a lot of other services worth taking a look under the CNCF app security landscape, not only for the security and compliance and the API gateways. You should check the service proxies, service mesh as well, and key management. There's like a lot of really good projects going on. And pretty much that's all, folks.